Are you ready? So, your revenue is demand. Let me write it here. Revenue is demand times the cost. So, your R of x is equal to D of x times P of x. And so that's equal to negative 0.25 x squared plus 1,000 times x plus 16. And that's equal to negative 0.25 x cubed minus 0.25 times 16 times x squared plus 1,000 times x plus 16,000. And then you're going to combine like terms, and you should have negative 0.25 x cubed minus 4x squared plus 1,000x plus a 16,000. And so that's our revenue function. R of x is equal to negative 0.25 x cubed minus 4x squared plus 1,000x plus a 16,000. All right, let's look at example 3, dividing functions. How do you define the quotient f divided by g of the functions f of x equals x minus 7 and g of x equals 2x squared minus 13x minus 7? To define the quotient of the two functions, take the quotient of their rules. So you're going to divide this by that, and we do have domain restriction because it's a division, right? It's a rational function. So x minus 7 divided by g of x, you can factor out g of x by 2x plus 1 and x minus 7, and then you can cancel out x minus 7, and then you have 1 over 2x plus 1. But the domain should be the same for your quotient as well from the original division. So this is only equivalent when the domain restriction is the same. So x cannot be negative 1 over 2 or 7. Okay. So let's look at try number 3, A and B. Identify the rule and domain for f divided by g for each pair of functions and state the domain. So pause the video, come back when you're ready for answers. Okay, are you ready? Let's look at 3A. So we have x squared minus 3x minus 18 divided by x plus 3. And you can factor out your numerator, x minus 6 times x plus 3 divided by x plus 3. And you can cancel out x plus 3. It just becomes x minus 6. But the domain is all real numbers except negative 3. So you have to state that x minus 6, where x is not negative 3. X is all real numbers except negative 3. And then 3b, we're going to divide x minus 3 divided by x squared minus x minus 6. And that's equal to x minus 3 divided by x minus 3 times x plus 2 if you factor it out. Now you can cancel them, and you have 1 over x plus 2. So the answer to part B is 1 over x plus 2, where domain is all real numbers except negative 2 and 3. All right, that was example 3. Let's look at example 4. Compose functions. Let f of x equals x squared and let g of x equals x plus 1. Investigate what happens when you apply the rule for g and then the rule for f to a number or variable. So part A, find the value of f of g of 3. So we're finding f of g of 3, which means you need to figure out g of 3 first, and then you're going to get f of that g of 3, right? So first of all, we're going to apply the rule for g. G of 3 is 3 plus 1, which is 4. So g of 3 is 4, and you can substitute that here, where now we're finding f of 4. F of 4 is 4 squared, so then that's 16. So f of g of 3 is going to be 16. Does that make sense? Yeah, so in order to get f of g of 3, figure out g of 3, and then figure out f of g of 3. All right, let's look at part B. What about f of g of x? So it's the same f and g functions, right? But you're going to apply the rule for g of x. Well, g of x is just x plus 1. And then you're going to put that in instead of x. So in your f of x, just change to g of x, where x is just your g of x. So your g of x is really x plus 1 as a rule, right? So you're, instead of x, you're going to substitute x plus 1 in there. And so your f of x is x squared, right? So instead of x, you're going to substitute x plus 1. And so x plus 1, all of that squared, would just be x squared plus 2x plus 1. Okay? So think about it one by one. You'll be able to figure it out. So let's try number 4a and b. We have f of x and g of x given. Identify the rule for the following functions, f of g of 2 and f of g of x. Pause the video, come back when you're ready for answers. Okay, are you ready? All right, let's look at 4a. We have f of g of 2. And so first, we need to know what g of 2 is in order to figure out f of g of 2, right? So g of 2 is 3 times 2. And so g of 2 is just 6. And so f of g of 2 is really equal to f of 6. And so f of 6 is going to be 2 times 6 minus 1. And so that's 12 minus 1, so it's 11, right? So this is just going to be 11. F of g of 2 is 11. Let's look at 4b. F of g of x. And so g of x is just 3x. So this is equal to f of 3x. And so instead of x, we're going to plug in 3x into your f of x rule. And so 2 times 3x minus 1 would be f of g of x. And so simplify that, you have 6x minus 1, and that's just 6x minus 1. So f of g of x is 6x minus 1. All right, that was example 4 and try 4. Let's talk about the concept of composite function. Composite function is a result of applying the rule for one function f to the rule of another function g. The new rule is denoted as f of g. So f of g of x could be written as f of g of x, okay? So the operation, this dot that forms a composite function is called the composition of functions. The domain of f of g is the set of all real numbers x in the domain of g, such that g of x is in the domain of f. And so the domain of the composition is the intersection of the domains of g and f of g, but not f. Let's look at example 5. Write a rule for a composite function. What is the rule for the composition of f of g of x? And so f of x is this, g of x is that. And so f of g of x would be f of 2x minus 5 because g of x is 2x minus 5. And so plugging that in, substituting 2x minus 5 into your x into your f of x function, you get square root of 2x minus 5 plus 7. And if you simplify, you just have a square root of 2x plus 2, and that's simplified. So the rule of f, the composition of f and g would be a square root of 2x plus 2. And the domain is everything greater than -1 because the radicand cannot be negative. All right, let's look at part B. X squared plus x plus 2 would be f of x function. G of x is 4 minus x. So the composition of the functions would be f of g of x, which is f of 4 minus x, which is 4 minus x squared plus 4 minus x plus 2. And then you simplify to get x squared minus 9x plus 22. So the rule for the composition of f of g would be x squared minus 9x plus 22, and the domain could be all real numbers. Let's look at try number 5. Identify the rules for f of g and g of f. So first, figure out f of g, then figure out g of f for both a and b. Pause the video, come back when you're ready for answers. Okay, let's look at part A. So first of all, you want to figure out f of g, which is f of g of x. And so you'll have f of with g of x, which is x plus 1. And so that's equal to x plus 1 cubed. And so then you can use the binomial rule, or you can multiply it out one by one. But you should get x cubed plus 3x squared plus 3x plus 1. Okay, so that's part A. And then 5b, wait, we didn't do g of f. So g of f would be g of f of x. And so g of x cubed would just be x cubed plus 1. And it's just x cubed plus 1. Let's look at part B. So 5b would have, so f of g would be f of g of x, which is f of x minus 5, which is x minus 5 squared plus 1. And so if you square this and add 1, you should get x squared minus 10x plus 25 plus 1. I'm not going to write everything. And then you're going to add 25 and 1 to get x squared minus 10x plus 26. Okay, and then g of f, which is be g of f of x, which is g of x squared plus 1, which is x squared plus 1 minus 5. And so that's just equal to x squared minus 4. Okay, so those are the answers for 5A and B. Check your answers, see if you got it right. If you did, great job. Let's look at example 6, the application problem. Use a composite function model. Composite function model. Clothes you wear, post discounts on social media. So that's a clothes shop. The store allows customers to use multiple discounts. They simply need to tell the cashier in which order they would like the discounts to be applied. On your next trip to clothes you wear, in which order should you ask for the discounts? So we want a cheaper total, right? So let's figure out f of g and g of f. Write functions to model the discounts for each one, and then you can figure out f of g and g of f to figure out which order we should go. So f would represent $5 off next purchase. G would represent 10% off next purchase. So f of g of x would be 10% off first, and then you get $5 off. F of g, and then and then g of f would be the other way. So yeah, I think there's a typo for this one. This should be g of f. Yeah, so g of f would be 5% $5 off and then the 10%. And if you look at the final functions, you see that they're the same 0.9x, but then you subtract 5 for f of g, and then you subtract 4.5, so you should get us a cheaper price for the first one. So this is a better deal. So if you plug it in for your cost, then you can provide like an example of that. So the first method would be a better deal. So let's look at try number 6. As a member of the Game Shop Rewards program, you get a 20% discount on purchases. All sales are subject to a 6% sales tax. Write functions to model the discount and the sales tax, then identify the rule for the composition function that calculates the final price you would pay at Game Shop. So pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? So first of all, you want to let of variable x equals a purchase price. And then you have a discount equation where d of x is equal to 0.8x, and then you have a tax. So tax would be something that you need to pay for. So t times t of x would be 1.06 times x. So your price gets higher, right? And so we can write function to model this, right? So you can, so we wrote the function models, and then we can identify the rule for the composition of function that calculates the final price you would pay at Game Shop. You get 20% discount first, and then you pay the tax. You can't do the other way. So this is only one option, really. You can't really choose. So you have to get the discount first, and then when you purchase with the discount, then you have to pay for the tax as well. So the only way that this works is t of d, where t of d of x would give you the correct function. And so let's write that function model where t of d of x is t of 0.8x, and that should be 1.06 times 0.8x. And so if you simplify that, that would be 0.848x. And so t of d is equal to 0.848x. Okay, that's it. You don't need to plug it in any numbers. Let's summarize our lesson. So concept summary for function operation is shown here. You can add or subtract function, and using this notation, you can represent the adding and subtracting of the functions. Multiply and dividing, composite functions would be represented by these notations. And then you should always check your domain as well. All right, so that was lesson 5-5 function operations. We'll continue with the next lesson in the next video. Bye.